Okay, year 10, this is now the third time I'm starting to record this video, so let's hope it goes right this time. Anyway, I'm on page 85 here in the notes. We're still in enlargements in our transformations topic in general. The work today is sort of the opposite of what we have been doing so far. So far we have been given the original shape, we've been given the centre of enlargement, and we have to enlarge it. We've been given the scale factor as well, and we have to enlarge it by that scale factor from the centre of enlargement. In the stuff that we're going to be looking at today, you've been given the original shape, but you've also been given the enlarged shape as well. And from that, you have to work backwards and find the centre of enlargement and the scale factor. Now, again, apologies, the grid lines have not photocopied on your notes, which is super annoying, but you can see here that I've tried to do it as lightly as possible. I've just rolled in where the grid lines are. It's a little bit easier than the ones from the other day because it's spaced out a bit more this time. So I've tried to draw on the grid lines as best as I could. It's not going to be perfect, but we'll do our best. And I haven't done it down here yet, but I will be doing it the same for that next example there. Anyway, the instructions are all up here on what we do. So let's read through it, right? To find the centre of enlargement, join corresponding vertices with straight lines. Now, corresponding vertices, that's just a fancy word for corners, right? So the corners of the shape, join corresponding ones together. And I think I mentioned this in one of the other videos, but the corresponding points are always like, so for example, A, and then the new version of A would be A dash, and those two would be corresponding. Now, the example's actually done it a little bit differently, but we'll look at that in a little bit. But that's what these two are corresponding to each other. Like the new version of the old one is corresponding to it. Now, what have we done? We've joined the corresponding vertices together with straight lines. The point where those lines intersect is the centre of enlargement. So if you don't get all of those, like for example here, because there's 3 points, there's going to be 3 lines. If they don't all cross at the same point, you've messed up a wee bit, right? So that gives us the centre of enlargement. Then to find the scale factor, we do the same idea with the wee table that we did before. Count horizontally and vertically from the centre of enlargement to just one set of corresponding vertices, and then you can calculate the multiplier. So it's honestly not that bad. The worst bit about this is the fact that the grid lines aren't in there. Anyway, let's look at this one here. So triangle ABC has been enlarged to give triangle DEF. Find the centre of enlargement and the scale factor. Now, see here, the way it says ABC is now turning into DEF. That means that the order of the letters is still the same. So A is corresponding to D. So D is the new version of A. B is corresponding to E. So E is like the new version of B. And C is corresponding to F. So F is like the new version of C. So that's the way we have to pair them up here. We join A to D. Okay, so wish me luck here on my funny, whatchamacallit, grid lines. Now, all I said I was going to do there was join A to D, but I extend them outwards because remember we're trying to find where these all meet. So they should all meet at one point. Yeah, they're totally going to. I think I've nailed my grid lines, I'm not going to lie. So I've joined A and D, but I've extended it, right? Then B corresponds to D, or sorry, E, flip me. So B and E are these two, so I'm going to join them up. And again, oh, I've messed up. I'm going to extend that line out. Okay, so they're meeting here currently. Let's hope the next one does. And then C is going to correspond to F. So I join those up and extend them on. There we go. So this here is our wee centre of enlargement. So we need to write down what that is first of all. So centre of enlargement is going to be the point 1, 2. So that's the coordinates of the centre of enlargement. And then we also have to find the scale factor. So we do the same little table that we did before. So So this one I'd be proud of me. Look, I'm actually using a ruler for my table. So the point, center enlargement to the point, center enlargement to the new point, a new point. So point, oh sorry, I'm not straight anymore. Center of enlargement to point, center of enlargement to new point, and new point. Now you only have to do this for one set of corresponding points or vertices. Honestly, does not matter. Let's just do the first one. So A and D. So our first point is A, and the new version of that is D. So from the center of enlargement to the point A is right one, down one. So one to the right and one down. Center of enlargement to the new point is 2 to the right and 2 down. So from here to here is 2 to the right and 2 down. So 2 right and 2 down. And then we're sort of working backwards, because remember last time we had this and then we were multiplying by something to get what these were. Well, now we have what these are. So we just have to see what's been multiplied by. So these have all been multiplied by 2. So if I was asked in an exam to describe that transformation, I would describe it first of all by saying what type of transformation it is. It's an enlargement with a scale factor 2 with center of enlargement 1, 2. Well, I feel guilty for summarising that. I probably should have written the words. Okay, hopefully that made sense. Let's look at number 4. This is one of those topics that I sort of think I don't like, but secretly I do like. Do you know one of those? Anyway, triangle ABC, so that's the original one. So this is our original shape here. Has been enlarged to give triangle DEF. So again, A is going to correspond to D, B to E, and C to F. Find the center of enlargement and the scale factor. Now, before I start, I'm probably going to draw my grid lines on here because I definitely think it helped me last time. So, here we go. Okay, there's my grid lines. She would never even know they weren't there. Okay, right, let me see. So, we need to join A to D. So, here's A and here is D. And remember, extend them on. Does that look right? Okay, I'm a bit scared about that one. Ah, not too bad actually. Okay, then I need to join B, here it is here, to E, which is that one. Okay, that's a terrible photocopy. And then we need to join C to F. There we go, they're all going to meet at one point. Right, so this is our center of enlargement. So write it in before we forget, because especially with these drawn grid lines, it's just sort of lines everywhere here. So the center of enlargement is 0, 2. Then to get our scale factor, we do our little table again. So we have our 4, 1, 2, 3, 4. We've got the point. We've got the center of enlargement to the point, we've got the center of enlargement to the new point, and we've got the new point. And again, it doesn't matter which one you choose. Let's choose, we'll just do the first one again. So A, new point D. So center of enlargement to A is 2 to the right and 1 down. So 2 right, 1 down. Center of enlargement to the new point, which is D, is 2 to the left and 1 up. So this time you can probably see what the answer is going to be. What have we multiplied by? The numbers have stayed the same, but the directions have changed. So that means that it's a negative. So we're multiplying by -1 here. Because the numbers really have just been multiplied by 1, but because the directions are like opposite of what they were before, that tells us that our scale factor is a negative. Okay, So again, describing the transformation, we've got it is an enlargement. Even though it's not getting any bigger, it still gets described as an enlargement with a scale factor of -1 with a center of enlargement 0, 2. Okay, that's it. Fun, isn't that? Okay, have fun with today's work.